In this video, I'm going to talk about tautologies and self-contradictions and how we can use truth tables to determine if a compound statement is a tautology or a self-contradiction or neither. So first, the definitions for these two things. A tautology is a compound statement that is always true. I just remember that because they both start with T. And then a self-contradiction is a compound statement that is always false. So if you are given a statement, a compound statement, here we have P or Q and not P, if not P, then Q. Okay. So we have this compound statement. We want to know if it is a tautology, a self-contradiction, or neither. So we will build a truth table for this statement, and we will look at our final column and analyze whether it is either of these or neither, based on the truth values we get in that final column. So as you can see, in this statement we only have P's and Q's. So it's only made up of two different simple statements, which means we're going to only have 4 truth value possibilities. They could both be true. It could be true then false, false then true, or false then false. All right, so the order that you go in, your truth table may not be exactly like mine. I'm going to go ahead and build this part, and then I'm going to build this part, and then I'm going to join them together with and. All right, so first I'm going to build P or Q. It's one of my basic truth tables. A disjunction or an or statement is true as long as one of its parts is true, or at least one of its parts. So true, true will be true, this will be true, this will be true. Those all had at least one part true. The only time a disjunction is false is when they're both false. So we have this piece built. Now I'm going to work on this. I need a not P column. So I will negate the P truth values for the not P column. And it will be false, false, true, true. Then I'm going to join that with a Q, a conditional statement. If not P, then Q. Now be careful because we have a lot going on here. So this is when I like to use colors to make sure I'm looking at the right columns. Okay, I'm going to use orange for this one. We're going to be looking at that first and this second. Now I mentioned in one of my earlier videos how a conditional is the only statement where we do have to worry about the order. So you want to make sure you're looking at this first and this second. Okay. All right. A conditional is only false when the first part is true and the second part is false. So let's go down this line. We have false, true, no. False, false, no. True, true, no. Here's one. True, false. That is the only time a conditional is false, when it's in that order, true then false. All right, so I'm going to go ahead and fill the rest of these in with trues. All right, now I have that piece built. Now I can put these two together with and, make it a conjunction. Okay, so again, we want to make sure we're looking at the right columns to make this. All right, so I'm looking here and here to build this. Okay, they're joined by and, so the order is not important. An and statement or a conjunction is only true when both parts are true. So here's one right here off the bat. True, true, that's going to come out true. True, true, that's going to come out true. True, true, that's going to come out true. But false, false, that's going to be false. So when we look at this final column, we see that they're not all true, so it's not a tautology. They're not all false, so it's not a self-contradiction. So this statement is actually neither of those. Okay, let's try another All right, so if we have P and not Q and not P, okay? And we want to determine whether it's a tautology, a self-contradiction, or neither. All right, so again, we need to build a truth table for this. You look at your statement, you see that you only have P's and Q's. So we're going to have 4 possibilities for truth values. True, 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 false, false, true, false, false. All right, I'm going to build the parentheses first. I've got a P, I need a not Q. So I'm going to build a column for not Q by negating the Q column or changing its truth value. So it'll be false, true, false, true. I'm going to put that together with P in a conjunction, an and statement. So I'm looking here and here to build this. It's an and statement, which is only true when they're both true. So I do see one where they're both true. I'm going to go ahead and mark that true. The rest will be false. All right, I'm going to need a not P column before I can build my final statement. So not P, or the negation of P, is going to change the truth values in the P column. So that's going to be false, false, true, true. All right, now I can build my final statement. P and not Q and not P. All right, so let's make sure we're looking at the right columns. I'm going to be putting this one and this one together with a conjunction. Since it's an and, the order doesn't matter. I'm just looking at these two. And is only true when they're both true. Do you see any situations where they're both true? No. So that means all of these come out false. And that means that this statement is a self-contradiction. Okay. I don't think I can squeeze another one in there. So let's get a new sheet and build a truth table for if P then Q or not Q. Okay, we want to know if this is a tautology, a self-contradiction, or neither. So we only have P's and Q's. So again, we'll only have 4 possible scenarios. True, 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 false, false, true, false, false. All right. Now, I'm going to build my parentheses first, so my conditional statement. If P, then Q. A conditional is only false when the first one's true and the second one's false. So it's right here. That's the only time it's false. Every other time it will be true. Now, before I can build my final statement, I need a not Q column where I go back and I negate the truth values of Q. So that's going to be false, true, false, true. And then I can build my final column for my statement here. Sorry, this truth table got a little janky. All right, if P then Q or not Q. Okay, so I'm looking at these two joined by or. Now, an or statement is true as long as at least one of its parts is true. So here I have at least one true, I have at least one true, I have at least one true, and I have both true, so that's at least one true. So because this came out all trues, we know that this statement is a tautology.